So today we're going to be talking about how we graph linear inequalities. Okay, so we've been doing graphing and we've talked about inequalities. We kind of want to merge some ideas we've already learned about and put them together. So first thing, if we think back several weeks now, right, we've talked about how we graph something like x is greater than 4. Okay, so if we want to graph something like x is greater than 4, right, we said previously that we couldn't write down all the numbers greater than 4. It was impossible, right? Because we'd have 4.1, 4.11, 4.111, right? We could do that forever, and that's not even getting to 4.2, okay? Much less 5, 10, 100, 4 million. So what we would do, right, is instead represent this on a number line, where we'd take the number that we have, putting that in the middle, okay, and then showing that while we start at 4, we can't actually include 4, so we would put an open circle, right? That meant we could get as close to 4 as we wanted, but we can't actually use the number 4. And then we would also shade to the right, because that would say, okay, any numbers that fall over here are numbers that are true. So whether it's 5 or whether it's a number way over here or whether way off my paper, right, anything that's larger than 4 works. So we're going to take that same idea today, but now we're going to talk about when we're graphing in the coordinate plane, because we have two variables. Okay, so what happens when x and y are both at play? So we still have this idea of an open circle and a closed circle and shading above and shading below, but because now we're making a line and we're in the coordinate plane, okay, our rules are going to be that if we have greater than or less than, we are going to use a dashed line. That's sort of going to be like our open circle. It's going to be an open line, so it's dashed. And if we have the or equal to, it will be a solid line. All right, so either dashed or solid. Okay, and if we are greater than or equal to, we are going to shade above. And if we are less than or equal to, we are going to shade below. Okay, so if you sort of were remembering, less than is left, in this case, less than is lower. Now, just like before, right, we couldn't graph these up here unless our variable was first. We have a very similar idea down here, except instead of, right, it being first, we have two variables, right? We're going to have to be solved for y. These rules only work if we are solved for y. Okay. Now, it's going to start off with ideas that we already know. And the idea is that if we are solved for y, we are in the form y equals mx plus b. So let's say we want to graph y is greater than 1/2 x minus 4. We are going to start off by forgetting that this is even an inequality symbol here at all, and we're going to treat it just like an equal sign. Okay, and if that was an equal sign, that tells me that m is 1/2. And b is -4, and I'm going to graph in slope-intercept form just like we've been practicing. Okay, so I'm going to go down to -4. I'm doing my b first. Okay, and then I'm doing a slope of up 1 over 2. And I'm counting twice to make sure I didn't mess up. Okay, but now instead of just throwing on a line here and saying that I'm done, right, this is sort of determining my middle of the graph, right? It's sort of determining where this 4 is in the middle, right? Can I stand on that line or can I not stand on that line? And that's determined by my inequality symbol. Okay, so that means anywhere along this line, right, we want this to be dashed because it's not or equal to. Okay, which means we can get up as close to this line as we want with values, but we can't actually stand on the line. Now, which direction we can approach from and get closer and closer is again determined by this sign. Okay, so this sign, this greater than sign, is telling us to shade above. Now, some students are better than this at others. It's called spatial reasoning. Some of our spatial reasoning is better than others, but if you kind of can't decide what's above and what's below, I always say imagine a bug walking uphill. Okay, so here's my little bug walking uphill. I'm a great artist. That's its antenna. It kind of looks like it has two heads now. Okay, and think about the sky being what's above it and the dirt being what's below it. Okay, and since we went above, right, all of this area is the sky. Now, I am going to give you way more info than you probably think you need on this, but it's going to be important in the long run. You really want to make sure you're shading correctly. Okay, so if you sort of shade just like right here in that little amount, that's not enough shading. Okay, if you decide to start like coloring this in solid and do all of this solid, that's going to be way too much shading. Okay, so I'm going to erase at least somewhat. You want to kind of find a happy medium. And the happy medium is that you want to go all the way across the graph and all the way up to the line. Okay, enough that it's shaded, but that it's not solid. Now, in your assignment tonight, it's going to be really easy because in Delta Math, it will just let you switch sides and do the shading for you. But that's just making sure we're not filling in anything too solid. Now, what does this mean? Okay, this means any place in this shaded area that we find an ordered pair. Okay, so maybe right here. This is the ordered pair 5, 2. That means 5, 2 is a solution. If I were to plug in 5 for x and 2 for y, I would get a true statement. Right, I've been really hitting hard on this in class that a line, when we've just been graphing lines, are all the x and y values that make the equation true. So this is all the x and y values. There just happens to be a lot more of them. Instead of them creating a line, they now create an area. Okay, and just like we had with inequalities, right, 4 isn't actually an answer, right? Points on this line, so if I pick this point right here, 2, -3, that's not actually an answer, right? Because it's on the line. We can get as close to it as we want, but we can't actually be on it. Okay, so let's say we're given something like 4x minus 2y is greater than or equal to 12. This is not solved for y, so we cannot graph in this format. Even if you say, well, it's standard forms, could I cover up? Our rules don't work over here, so we really need this to be solved for y. Okay, so to solve for y, we're going to subtract our 4x. Oh, that's an x. Sorry, guys, I can't write and talk. So I have -2y is greater than or equal to a -4x plus 12. And then we're going to divide by -2. And you might be going, should I be remembering something with a negative? Yes, yes, you should. When we divide by a negative, right, that tells us to flip the direction of the inequality sign. And so we'll have y is less than or equal to 1/2 x minus 6. So to graph this, my b is going to be -6. So I'm going to go down to -6. My slope is up 1 over 2. Okay, now this inequality symbol is telling me to use a solid line. Now I want less than, so if I have a bug and it's walking uphill, oh man, this bug's even worse, right? I want below, I want the dirt, I want the ground, and that's all the stuff down here. Okay. What if I said I wanted to graph y is greater than 5? And so we say, okay, that means my m is 0 and my b is 5, right? We've already talked about that with slope-intercept form. So I'm going to start at 5. I have a slope of 0 over 1, so I'm going up 0 over 1. Up 0 over 1. This is a dashed line. And this one is telling me to shade above. All right, so I'd have this area here. I can also do graphs like x is less than or equal to -3. Now, if you remember this one, right? Our x equals line, we have an x-intercept at -3, and then we cannot cross the y-axis. So this is our vertical line. It's solid. Okay, and I'm gonna shade below. Now, this one's a little bit weird because I don't have an above and a below, right? This has always been the one that lays outside the norms, right? Because a vertical line isn't even really a function. So this is just our equation in here that we can graph. But this just falls back to our old rules, right? Numbers less than -3 are numbers like -4, -8, -10. Less than is left. And so we're gonna shade all this area over here.